So we got a circuit there with a battery, a switch, a resistor, and a capacitor. Anytime you have a resistor and a capacitor, you immediately can talk about it with T equals RC. That means the time constant is equal to the resistance. T equals RC, resistance times capacitance. Needs to be in your notes. Remember, inductors was 1 over R, 1 over L. Okay, so it was RL. T equals 1 over RL. It's T equals RC here. Okay, just the opposite. And what does that really mean? Well, that little circuit has a resistor and a capacitor. When we look at the circuit, what we're really looking at is the time that it takes R1, that the circuit takes to charge up C1 through R1. So R1, it depends on what size it is, and C1 depends on what size it is. If I have a large electrolytic capacitor for C1 and a large resistor for R1, the time constant is long. And if I use a small C1 and a small R1, it's short. Remember our 555 timer? What was on the side? We had the resistor from power that actually charged the circuit, so it limited the current when it flopped over. But the resistor and the capacitor were right there for the time constant. We used what? A 10K and then a 1 microfarad. Then we used a 10 microfarad, and it went to ground, so it charged up and discharged, charged up and discharged. And that circuit that we looked at actually showed the charge up and discharge, and that caused our flip-flop to flip back and forth. Okay? So this time constant T right here is developed by these two right here, and you will see them somewhere. You'll have to identify them. They might have some glue circuitry around them like that one did, so it didn't short out. But they'll be in there somewhere if there is an RC circuit. Now, that's for the figure 11.7. Figure 11.7 shows our resistor and our capacitor, and it shows a electrolytic, if you notice. Okay, and they do a little bit of calculations here. We'll do one here in a minute. But if you look on the next page, you will see a graph, and it's like the one I gave you. Okay, and notice that the time periods go from 1 to 5, and then it's charged, and then from 0 to 5, I should say, and then 0 to 5 for discharge. Notice the 63.2%. That's where most of them are going to cut off because they're not going to wait around for 5 time periods. That's not always true, but for the most part, that's what you're going to see in the field.